So let me ask you, what is a variable?
Is it a value stored in a location?
Okay, it's a memory location that has a value. And can that value change?
Yes, it can.
Yes, it can. Yes. Okay. So that is a variable. It's a place in memory. Okay. What about variable name? How do you make sure your variable name is correct? What are the rules, everybody? Okay, I'm going to call you now. What are the rules? How about I stop this recording? Let me see. Since we are reviewing, right? What are the rules of variable? Justin, that was you who are talking, right? Repeat
Yes,
what
ma'am.
you said. How do you start? How do you have a good variable name?
As far as starting it, just lowercase.
Yes, lowercase.
No numbers, no like things like that. Sorry.
And you said camel case. What is camel case?
So basically, the first word is not going to be capitalized, the first letter on each word, but every word after that, it's basically kind of acts like a space, but it's just going to be capitalized instead of like a space in between.
That's very good. That's correct. Absolutely correct. Okay. Thank you. Another question. Can you have a digit inside the memory, inside the variable name? Can you have a digit in the variable name?
Yes.
Yes, you
Yes,
can.
but it can't be at the beginning, I believe.
That's very good. That's absolutely correct. You can have digits, but it cannot be at the beginning. Very good. Okay. So that is variable names. We discussed that already. And here is what that is. So a constant is simply a final variable. That means once it's declared, you cannot change, right? We discussed that. And then this is here. This is the string concatenation. This is adding a space between those two strings, right? Okay, we discussed that. So now let's talk about program comments and docstrings. Did we? We didn't. Okay, we discussed docstrings a little bit, but so here, program comments is a piece of program text that the computer ignores, but that provides useful documentation to programmers. So this is comments documentation. They are used interchangeably. That means you can say something is a comment, something is documentation. What it is that it documents your program. It explains your program. It tells the reader what this code is doing. Okay, so it's the explanation for the code. So why do we need that? Because sometimes you write complicated code, and later on you don't remember why. You don't remember the logic because you write so much. So you comment, you put your logic, you explain the logic there. Okay. Another way, another purpose is that when we do a system, when we do a project, it's multiple people working on the same system, the same program. So people have different logic, and when you integrate, everybody needs to understand the code, right? So you need to write comments so that other people understand why you did that. And sometimes some people was fired or some people left the company, then their code will be able to be understood by other people if you provide comment. So it's very important. Now, comment has two formats in Python. One is this docstring. So if you look at this, we discussed this when you print. If you remember, we discussed the print previously, right? When you do this, you will print this exactly like this. If you don't use print, then it's just documentation. The computer, the Python interpreter will ignore this. So it will simply not care about this at all because of the three double quotes. So that's called documentation or comments. Okay. This is when you have multiple lines. When you only have one line of comment, this is what you use, the pound sign. If you only have one line, okay. So just like this, this is called an end of line comment. Okay, so you just use this symbol. And so that's how you comment your code. And from now on, you will comment your code. You need to get into that habit so that you don't, a lot of people, they don't provide the comment, they just write it and later on provide it. Is that good? That's okay. But you know, as you are working out your logic, put your comment there so that you remember why you did that. Okay. So tips related to comments and docstrings. Begin the program with a statement of purpose and other. So it's like this, right? This is a good habit to have. When you start a program, always have some docstrings to explain the purpose and other meta information. And accompany a variable definition with a comment that explains the variable's purpose, precede major segments of code. So this is not asking you to comment on every line, okay? When we say comment, sometimes students overdo it. Do not do it in excess. Just precede major segments of code with comments. You don't want to comment on each line, just a segment, a segment, a segment. Okay. Include comments to explain the workings of complex or tricky sections of code. So that's what that is. Okay. Let's look at how you can go ahead and start your Python, and we can write something. For example, you will, I think this is better. Okay. I cannot move it. It's here. Okay, I will move it here. And so, am I recording? Yes, I am. Okay, so here, and we will, this is how you start your program, your comment, right? This is an exercise for comment. Okay, and you can end it, right? What's wrong? Okay, so this is a comment. This will be ignored by the system. And then you can write, okay, if it's one line comment, you will say hello. And you will do something like this, okay, print out hello to the screen, something like that. And print, you know, so let's run it and you will see the comment is ignored. I will save it on the desktop, okay? Okay, so now I will run and you can see it. Oh, I always do that. This is terrible. Okay. So you can see it prints out hello and what's up. So all these will be ignored by the interpreter. The computer doesn't care about it. This is really for human beings, okay? Any questions? Okay, let's continue. Now let's talk about numeric data types and character sets. Okay, the first applications of computer were to crunch numbers. That's correct. We always use numbers to do programs, right? To process text, to process anything. The use of numbers in many applications is still very important. Okay, integers, and you understand what integers are. So that's easy to understand. These are integers are numbers without decimals, right? This is the range for integers. Okay, that's the range for integers. This is not an integer. This is the comma style used in finance or large numbers in essays or research papers, but not for Python, not for programming. For programming, you will always use integers like this. No decimal places, no thousand, no, I'm sorry. Yes, decimal places, but no thousand separator. This is called a thousand separator. You don't have that. Okay, this is correct. Floating point numbers. Floating point numbers are numbers with decimal places. We discussed that already. Real numbers have infinite precision. Okay, just like 10 divided by 3, it's infinite, right? So the digits in the fractional part can continue forever. Python uses floating point numbers to represent real numbers, and the type is float. We discussed that already, and this is the range. See how big that range is, right? Typical precision, 16 digits. That means after 16 digits, it doesn't matter anymore. So if you have a number like this, okay, can I write 16 digits? Okay, so here, after 16 digits, it doesn't matter anymore. So these digits are not cared for. No one cares about them. They are ignored, really. So typical precision, 16 digits. That's what that means, okay? Even though you have them there, it doesn't matter to the computer anymore. For this type, for this float type, okay? A floating point number can be written using either ordinary decimal notation or scientific notation. So here is the scientific notation, right? Okay, so you understand how to do that. So when it's too big, you will use scientific notation. Something like this. This is a longer, you might want to use. This is not long enough, but this shows you this is scientific notation. Okay. You can either write it this way in your program or this way. Okay. Character set. Okay. We discussed int and float already. So now let's look at character set. In Python, character literals look just like string literals. Okay. So for strings, I think I mentioned this, you can use double quotes or single quotes for strings, right? So you can use something like this, or you can do it like this. And I remember I told you, get into the habit of using double quotes, because in other programming languages, you use double quotes, not single quotes. So you want to use double quotes, but single quote will compile and run. So in Python, character literals look just like string literals and are of string type. So in Python, there is not a different type for a single character. It's the same type, it's string, okay? They belong to several different character sets, among them the ASCII character set and Unicode set. So the ASCII character set uses 8 bits, which is 1 byte, okay? 8 bits. So you have 8 little triple crossing, copper tracing there, and you can change this to 0 or 1, okay? So if you change it to a pattern like this, this becomes an A. This becomes uppercase A, okay? If you encode it like this, this will be uppercase B. And if you change the combination into something like this, you can see the pattern here, right? This would be C, and so on. So this is what character set is. That means every character is remembered and stored in the computer as binary numbers. So this is the capital letter A. This is how it's stored. And this is 8 bits, so it's 1 byte. This is called ASCII. Okay, now ASCII set has only 8 bits, right? So if you think about it, how many combinations can you have with 8 bits? You can only have at most 256 combinations. And if you think about the languages in the whole world, there are more than 256 different symbols. So this Unicode, this ASCII set is not enough. So nowadays we use 2 bytes, that's 16 bits. And that's how many different characters you can have. It's 63335 or something. Okay, so it's a lot, and that's enough for all the symbols in all the languages in the world. So that's called Unicode. Okay, so basically ASCII uses 1 byte and Unicode uses 2 bytes. And ASCII is a subset of Unicode. So what that means is, my internet connection is, what that means is you simply add 8 zeros before it. Okay, so it's still, the coding is still the same if you look here, right? But the preceding 1 byte is 0 because you don't need it. But if you have a character, let's say a Hebrew character, it's very complicated. You might need this part. But for English characters, these are all preceding zeros. But now you have 2 bytes. That's the Unicode set. Any questions? Okay. So all characters are encoded into nowadays Unicode character set, characters, okay, using 2 bytes to store them. So each character will have a value because these are actually, okay, this is actually a number. If you convert it into a decimal number, this is 65. That's how it is converted, because this is 2 to the first, this is 1, this is 0, 0, 0, 0, 0. This is 2 to the 6, and that is 64. Okay, 64 plus 1, that's 65. That's how it's encoded. You don't have to know that yet, but you can look into it if you want to. I'm not going to test you on that, but it's good to know because you are a computer science person, right? You want to know everything. Okay, so that's why we can use this ordinal value. This is ordinal. Okay, ordinal is a function, and you put the character there, it will give you the value. So for lowercase a, the value is 97. For uppercase a, the value is 65. So ordinal. This is, we call this a function, okay? And you give it a character, it will give you a value. Let's look at this. Okay, so we will say odd a, right? It gives you 65. Odd space, it will give you 32. So you know that in memory, the space is remembered as the binary value, binary digits of 32, okay? And so if you want to know the character for a value, this is the function, CHR, character, and give it 32. It will give you the space, right? They are inverse of each other. Give it 65, it will give you the character A. Okay, so you will print char, give it 123. It will give you that curly braces. So that's how you use those functions. They are called functions. They are called functions. A function means you have a name And then you have this parenthesis, and inside is the argument, just like print. If you remember, print is a function, right? Whatever you want to print, you put it inside the double quotes. And this is a function. It gives you the ordinal value of a character. So you put it inside, the character inside. And this is a function. It will give you the character for a value. So you give it a value, it will give you the character. Okay, any questions? Now, I will let you do this. Get and print out the numerical value of Z and a question mark in a complete sentence. Why did I say get? You don't have to get, right? You can simply do it. So just print out the numerical value of Z and this in a complete sentence. So this means you will say the character Z has the numerical value of. You cannot do that. I'm not going to ask you to do that because right now we haven't learned that yet. So let's just print out the character, the value of character, the ordinal value of Z and question mark. Let's do that, everybody. Remember to record this. Okay. Print, yes, and get the number and print it out. Print out the character and get the character and print it out the number. That's very good. Yang, let's run it. We cannot see your execution screen though.
Oh, sorry, Anthony.
Oh, okay. So can you show the code also at the same time? When you share screen. Don't share individual window. Just share the first one screen this way.
Okay, like this.
Okay, let's have both windows on. Yes, good. Okay, everybody, let's look at this. This is the code and this is the output. That's absolutely correct. Excellent. Very good. Very, very good. Oh, okay. Everybody got that? Very good. Correct. Thank you. Okay. Anyone else who wants to share? I will give you another chance. Anyone else? Anyone else who wants to share? No?
I'll do it.
Okay, let's look at yours.
All right, somebody give me a number.
You can just enter any number, Omkar. Okay, the character for very good, very good. So you did print. Everybody look at the code. He printed out the ordinal value of Z and question mark on the same line, in the same line, on the same line. Okay, and get the number, and then you did num input. You convert it to an int. That's a little bit different from what we did, but I hope everybody understands that. And then you print it out. Yes, very good. Very, very good. Thank you, Omkar. Very good.
So I accidentally muted myself.
Okay,
this is
very,
what I
very
wrote.
good. That's absolutely correct. Everybody look at the code. One string, but when you print it out, it's on two lines because you are using an embedded new line character. Absolutely correct, Marilyn. Thank you very much.
Okay.
Okay, good. Good. So let's look at this one. How does one include an apostrophe as a character within a string literal? How do you do that? Everybody?
With an escape sequence, the backslash and the single quote.
Yes, very good. That's correct. Using the escape sequence character backslash single quote. Correct. Very good. Thank you. What happens when the print function prints a string literal with embedded newline characters? We just saw that from Marilyn's work. When you embed a newline character, it goes to the next line. So that already answered this question. Am I recording? Yeah, I am, right? I am. Oh, but I'm not sharing my screen. That's why. Okay, so we just answered this question just now. We answered this question and we answered this question, right? So now let's look at number 5. Which of the following are valid variable names? A, valid? Yes or no?
Yes.
Yes. B,
Yes.
Yes.
yes. C,
Yes.
Yes.
yes. D,
No.
No,
no. Why?
because it includes the number first, I want to say,
Yes,
or
yes.
the M is capitalized first.
Yes, you cannot start a variable name with a digit. That's correct. E,
No.
no, why not?
It contains a special character.
Yes, it contains a special character. Okay, very good. Those are that. So I went back to review, right? Let's go to page 49. Okay. I think this is good. I'm going to do this from now on. So not only do I give you exercises, we look at these exercises in the book to reinforce the concept. Okay, which data type would most appropriately be used to represent the following data values? The number of months in a year, what data type should it be? Int, okay. The area of a circle.
Float.
Float. The current minimum age.
Float.
Not age, but wage. Float. Do you all agree, everybody?
Yes.
Yes. Okay. The approximate age of the universe.
Int.
Int is too small. It might be too small for this. It is. It's not might. It is too small. This is 12 million.
It would be float
Billion.
because it's approximate.
Float?
So what did you say? Kobe, what did you say?
Is it float?
I didn't hear you, Kobe.
Is it float?
Yeah, it might have to be a float.
You're saying it's float.
I think int is too small for this number. Okay, it might have to be a float. I'm thinking in other languages, there is long. In Python, it doesn't have long. So you want to use a float. And then you can use what type, what kind of notification? Scientific notification, right? Instead of writing so much, you can use scientific notification to express this. Okay, your name.
String.
String, yes. Explain the differences between the data type int and float. That's easy. What is an int?
It has
Whole
a
number.
decimal.
Whole
Oh
number.
yeah, the whole
Float
number. Has a
Is
decimal.
decimal number. Right, the values of the following floating point numbers in Python's scientific notation. Can you do that, everybody? This would be 3.5576, right? And then E 10 to the second, E2, okay. And this would be 7.8 E, 7.832 E -3, right? Because, okay. And this would be 4.3212. E0. It should be, this is exactly correct. So, okay. Consult table 2.5 to write the ASCII values of the character $, and this. You know what? Instead of consulting, you tell me, write using your program, use your Python program statement to tell me the value, the numerical value of $, and %. Okay. So someone, did someone do this already, or do you want more time?
More time, please.
Okay. Let's see. So that is print. Good, very good, everybody. Okay, Jordan, thank you. Very good. Okay, expressions. Okay, let's talk about expressions. Expressions, a literal evaluates to itself. A variable reference evaluates to a variable's current value. You understand this? A literal evaluates itself. So if you have something like this, that's itself, right? But if you have a variable, then when you reference this variable, it's the value that is used, right? When you say num, you print it out, then this value will be printed out. That's what this means, okay? Expressions provide easy way to perform operations on data values to produce other values. When entered at Python shell prompt, and expressions operands are evaluated, okay? So when you do this, num is 2, x is 3. So at the Python shell, if you do num plus x, the system will go to num to get the value which is 2, and go to x to get the value which is 3, and add them together, it will give you 5. That's what this means. The expression's operands are evaluated. Its operator is then applied to these values to compute the value of the expression, okay? So that's what this means. Arithmetic expressions. Let's look at these operators. This is subtract negation. Okay, this is negation here. So you understand that. This is exponentiation. This is a raised to the power of b. Okay, 4 double stars and then 2. This means 4 raised to the power of 2. Why is it 14? It should be 16, everybody. Okay. It should be 16. Okay, so this is multiplication, right? This is easy. This is division. This is easy also. And now you have a different division operator. We call this, in Python, it's called quotient. What that means is it gives you the integer value. Okay, so 11 divided by 4, if you do, let's do 11, I will do it here. 11 divided by 4, right? You have 2, and that's 8. And now you have a 3. So this is the quotient. This is actually the remainder. That's the difference. So if you do 11 divided by 4, that will give you, that will continue. Okay, that will be 11 divided by 4, 2, 8, 3, you put that there, 7, and then you have 2, and then 5, right? So this will be this, and this is this. That's the difference. That's quotient, that's division, okay? And this is the this is the percentage sign, but it's called remainder. That means it will give you the remainder. So it's 11 divided by 4 and the remainder, which is this one. Okay, that's the remainder. And this is addition, subtraction. That's easy, right? Okay. So how do you make sure you understand this? I give you this example here. 12 divided by 3. This will be the result of this operation, the quotient. And this is the result of this remainder. It's also called modulus. Okay. And this, oh, we just did this. No. Okay. This is the quotient, this operation. And this is the remainder. That's the result of this operation. Okay. And this is the result of this operation. So those are the three that are a little bit confusing. These two are not confusing. You just need to differentiate them. And this is new to you, I believe. So, okay, another thing to remember is with integer division, if the first operand is less than the second one, the result is 0. Here is this, 4 divided by 7. Right? This is integer division. We call that integer division, really, quotient. So you have 0 sevens in 4. Then the quotient is 0. And the remainder is 4. So if you do 4 modulus 7, this is the remainder. Okay, let's do that. Let's do, for example, 4 divided by 7. Okay, that gives you the division. That gives you the accurate result. 4 integer divide 7, that gives you 0, right? 4 modulus 7, that gives you 4. That's the remainder. 10 divided by 3 will give you 3.333, right? 10 integer division by 3, it gives you 3. And 10 modulus 3, what does that give you, everybody?
1.
1. Yes, that's correct. Okay, because the remainder is 1. So that's this part. Any questions, everybody? No questions? Okay. Precedence rules. This exponentiation has the highest precedence and it's evaluated first. Okay, so unary negation is evaluated next. That's negation. And then these have the same level, but they are evaluated before addition and subtraction. You know that. You know that from elementary school. These are evaluated last. But this actually, assignment operator is evaluated last. Okay, so remember I told you anything on the left-hand side is the destination. Everything on the right-hand side has to be evaluated before you assign it, right? So this is the last stop. The equal sign is the last stop, last step. With 2 exceptions, operators of equal precedence are left associative. Okay, operators of equal precedence are left associative. What that means is, look at this expression. They are addition and subtraction. They have equal priority. Then you go from left to right. Okay, so you will do subtraction 1 plus 5, 6 minus 3, 3. Okay. That's what this means, when they are equal. But when they are not equal, when you do 3 plus 2 divided by 3, you have to do this first, right? So, but if they are equal, you go from left. This one and this one are right associative. That means you do the right half first. So you always evaluate the right first. For example, now you have this expression. Which one do you evaluate first? You do the right part. So 3 raised to the power of 2 goes first. Okay, that would be 9, right? And then you do 2 raised to the power of 9. That gives you 512. Okay, so exponentiation and assignment always are right associative. Okay, so this is the assignment operator. You will do this side first, right side first, and then assign it to area. Okay, so that gives you the two examples for this statement. Any questions? You can, of course, always use the parentheses to change the order of evaluation like this. Without the parentheses, you will do this first, but with the parentheses, you will do this first. Okay, you understand all that, right? Let me see what, okay. So arithmetic expressions continued. When both operands of an expression are of the same numeric types, the resulting value is also of that type. When each operand is of a different type, the resulting value is of the more general type. Okay, here is what it means. Okay, so 4 times 3, both of them are int, right? So the result is 12, an int. But here, when you have 3 divided by 4.0, this is not an int, this is a float. So your result will be a float. If it is 3 divided by 4, it will still, it will give you the 0.75 also. But if you have, okay, this is not a good example, I think. Okay, let's do this. 8 divided by 4 will give you 2. If you do 8.0 divided by 4, it will give you a more generous type, 2.0. Let's see. I believe that's what I was trying to say. 8 divided by 4, it also gives you 2.0, huh? So that doesn't apply here. Then. Okay, so I might need to revisit this. This is not necessary to know because it's by default true. Okay. But when you have a float in your expression, the result is definitely a float. Okay. In this case, this is more general. I think I should delete that statement. That's not applicable here. It's applicable in other languages, not in Python. Python is a very lenient language. Okay, so I'm recording, right? 3 divided by 4, this is asking for the quotient is 0, right? When both are int. But when you do this, one is a general type, a more general type, float, then the result is 0. This makes more sense. It gives you 0. 3.0 divided by 4, it gives you 0.0. Okay, that makes more sense, right? Everybody, do you understand me? Or did I confuse you? I cannot hear anything. So what I will do is I will take this off. That's a little bit confusing there. Okay, so we don't have that. This will make more sense. 3 divided by 4, you're asking for the integer division result. It's 0 because both are int. Okay. When each operand is of a different type, in this case, this is an int, this is a float. The resulting value is of the more general type. So the resulting value would be 0.0 because 1 is a float. Okay, and float is larger than int. So the result will be a float. Here, both are int. So the result value is the same as that type. Any questions? No? Okay. This really doesn't apply that much. You don't. For multi-line expressions, use a backslash to continue on to the next line. So if your expression is too long, you will go down. Okay. This is equivalent to this. right? Without this. But if you want to go down, you can do that. That's what that means. Any questions, everybody? No? Okay. Let me see if we should do some exercise. Oh, yeah, let's do this one. Let's look at this first, and then we will look at some exercises. Okay. Should I do this? Yeah. Okay. Let's look at some exercises first. Everybody, let's look at this. Let x be 8 and y be 2. Okay. Write the values of the following expressions. X plus y multiplied by 3. What's the value? What's the result for this expression?
48.
48.
Actually, 14.
14. Okay. Everybody, anyone else? What's the result? Should I call you, everybody? Hudson, what's the result?
14.
14. Okay, 14. The reason is that, oh, if I do that, I cannot do that. The reason is that we do this first, which is 2 raised to the power of 3. That would be 8. 8 plus 8. Oh, what did you say just now? 14? Why is it 14? Oh, this is multiplication. I'm sorry. It's not raised to the power of 3. It's multiply. So it's 2 times 3. That's 6. 6 plus 8. That's 14. This one. What about this one? Ariel. What about that one?
30, ma'am.
30. Okay, that's correct. 2 plus 2, 8. That's 10. 10 multiplied by 3. X raised to x and the 2. Okay, just tell me what this is. I won't tell you what that is, right? Okay. Carlos, what about this one?
64.
Carlos, I'm sorry?
64.
64, okay. 8 raised to the power of 2. 8, 8, that's 64. That's correct. What is this one? Macarene.
Oh, 0.
0, why?
Because it's the remainder. 8.
It's the remainder. 8 divided by 2 is 4, and the remainder is 0. That's correct. Very good. Okay, what about this one? Kelsey. First of all, Kelsey, tell me the result will be an integer or a float. Kelsey, I cannot hear you. Kelsey, can you hear me?
She's typing in chat. Her mic has been having issues today, she said.
Okay, okay. So what did she say? What are you saying in chat? Okay, what did she say?
She said that it would be an integer.
It would be an integer. Okay, thank you. Caitlin, what do you think? What's the result?
I think it'll be like a float or like a decimal.
A float. Why?
Because sorry, Han. Because you can't like divide
Arithmetic expressions when we did this. Mixed mode arithmetic. Okay. Didn't we do this already? We did this one. You understand. You will do the exponentiation first, right? Mixed mode means different types. So you do this one first and then do this, and it gives you the more general type. Okay. You must use a type conversion function when working with the input of numbers because the input function returns a string. I discussed this the second day or the third day of class. So whatever you enter on the keyboard, it will be a string. If you want to treat it as a number, you must convert it into a number. And here is how you do that, right? You are familiar with this. How many books do you have? You obviously are asking the number of books. This should be an integer, so you convert it into an integer. And this itself gives you a string. And this will give you an int. Okay, so the function is int, a number inside. So if you do this, this will convert this string into an int. Okay. And price of book, you convert it into a float because the price is 1.9 or 10.9, so it's a float. That's what this means. It is a function with the same name as a data type to which it converts, such as float and int. So these are functions, float, int. Without the int or float function, the digits you enter meant to be a number will be treated as a string and you cannot perform any calculation on it. Okay, so here, let's look at this example. Price of book, I did not convert. I just asked the user to enter. So the user entered some numbers, but it is a string. So if I want to calculate using it as a number to do the calculation, it does this. You remember this, we did this last time. Hello times 12 will output hello 12 times, and this will output 29.99 12 times. No, yes, 12 times. Okay. When you do this, it will say, no, I cannot do that because this is a string. I cannot combine a string and an int together. So that's the problem. That's why you always remember to convert it into a number. Okay, you can do the conversion like this. Note that the int function converts a float to an int by truncation. It doesn't round up, it simply discards the decimal places. So the result is 6. There is another function that's called round. This will round it up. Okay, so when you do this, you get 34. When you do this, you get 35. When you convert 34 and int into a float, it gives you 34. Okay, so these are the rules, examples, and the values. Any questions here, everybody? No? Okay. Okay, I think I want to stop here for a minute and let's go to our exercises. Okay, so let's look at this. Let x be 4.66, write the values of the following expressions. So what will this give you back?
5.
5. Okay, round will round up. Yes, it will give you 5. What about this one?
4.
4. Yes, it will truncate the decimal places. So this is integer conversion. This is rounding up into an int. Okay. How does a Python programmer round a float value to the nearest int value? We just saw that, right? Round. Okay. Concatenate. Okay, that's something we haven't learned. So, okay, let's go back here. So we go to the next slide. Mixed mode arithmetic and type conversions. Continued. Okay. Type conversions also occurs in the construction of strings. from numbers and other strings. So let's see. Okay, when you say profit is this is obviously a float, right? And you say print, this is a string, concatenation, and the profit, it will not go. It will say type error, cannot concatenate string and float objects together. So this is a string object, this is a float object. You cannot put them together. To do this, you must convert the float into a string. So just now we saw that we convert a string into an int, right? This will convert this string into an int. Now we use this function to convert an int into a string. So this will give you 12. Let's see. Restart. Oh, it's still here, right? Okay, it's at the bottom. So when you say int, this will give you an int. Okay, but you can convert that int into a string. So this will give you a string. That's the conversion. And you can convert a float into a string. Okay, you can convert a string into a float. Okay, so those are the conversions. Any questions, everybody? And because now you have two strings. One string, this is also a string, so now you can print this out. But you cannot do this plus profit. You cannot do that because profit is a float. You have to convert it to a string. Okay, instead of doing that, we will do that next time. Let's look at this. Okay, how does a Python programmer concatenate a numeric value to a string value? How do you do that?
You convert it.
Convert it to a
How?
string.
What do you use to convert?
str.
A string.
Yes,
str.
yes, very good. str, that's the function. To convert a string to an int, you use int, int. For a float, you use float, float. For string, you convert using str, that's the function. Okay, assume that the variable x has the value 55. Use an assignment statement. Oh, we haven't learned this yet, have we? Oh, yeah, we have. We can do this. Anyone who can do this? So basically, it's saying x is equal to 55. How do you increment x by 1? Let x be 56. How do you do that? Everybody?
X plus 1.
We want x to be 55 from now on. So if you simply do x plus 1, x is still 55. How do we make sure x now becomes 56? Anyone?
X plus equals 1.
So you make x into the variable, so x equals, and then you can put like int 55, and then I don't know if I'm explaining that right. I'm sorry.
Okay, Omcar said something, but we haven't learned that. So I want to know if anyone else, how do we, you see this, right? X is 55, X plus 1, that gives you 56 at that moment, but X itself still contains 55. It didn't change because this is an expression. And so how do you change X? How do you change a variable's value? Did we learn this? I don't remember.
I guess you could just, yeah,
Then?
x plus 1, yeah.
Okay, So when you change a variable's value, I don't remember if we learned this because I'm teaching Java and this class at the same time. So I don't remember. Did we do this?
I don't think so.
I don't think so.
So
Okay, we will, but now you know. So this is, remember for assignment, we always do assignment operators, it's right associative, right? What that means is it evaluates the right side first and then assign it to the left-hand side. So x is 55, you plus 1. Now this expression gives you 56. And then you assign it to that variable. You place it into the location, into that location. So now x is 56. But only do this. It doesn't change the variable. To change a variable's value, you must use the assignment to change it. This is simply an expression at that moment. It doesn't change anything. Okay, x is still 56. Oh, uppercase. I did uppercase. Okay, it's still 56. Only when you do x is equal to x plus 1, now x is changed. Okay, so to change a variable's value, you have to use an assignment. That's that. Okay, I think that's all the, yeah, that's all the exercises in the book. And here is the here is my exercise for you. I don't think we have enough time to do this. Now it's 25, our class ends at 35. So I will not let you do this. We will do this next class. But go ahead and do it on your own, right? It's fun, you want to do it. And then next class, the first thing we do is to do this exercise, everybody. So I'm going to stop recording.